Hello, Algebra 2 CP students. Hopefully you're having a fantastic day so far. Today, I would like to continue our discussion on the quadratic formula. I have two examples prepared for you of quadratic equations that are solved using the quadratic formula. The first of which works out using pretty nice numbers, and the second one is a little less nice with radicals and i's showing up, but we'll get to that when we get to that. After those two examples, I have an application, aka a word problem for you, that is solved using the quadratic formula. When we get to the word problem, you may notice that at first glance, it will seem a little daunting and overwhelming. There's a lot of information, but really all it entails is using the information it gives you to build a quadratic equation and then just solving it using the quadratic formula. So we'll get to that in a little bit. Let's start with these couple examples now. The first of which is right here. 6x squared minus 4x minus 47 is equal to negative 5. Remember, the quadratic formula states that if we have this situation here, the standard form ax squared plus bx plus c equals 0, so if we're set equal to 0, we have our quadratic equation in standard form, then we can say that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That was probably a little boring, me just saying the formula to you. Much better and much catchier if I sing it, because of course we have a quadratic formula song. It's definitely a little silly, but it helps it stick in your head. It's to the tune of Pop Goes the Weasel. I did it last video. I did it on Monday. We're doing it again. It says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's the quadratic formula song. Come on, that's at least a little catchy. How do you not enjoy that? That, believe me, is going to help it stick in your mind, because for an assessment, you're going to have to know the quadratic formula. And guess what? If you don't commit that to memory, you don't adopt the song, you don't embrace the goodness of the quadratic formula song, well, come test time, it's going to be really difficult to try to recall that from memory. So just telling you from past practice, believe me when I say it works. All right? Anyway, we can go ahead and use this formula to solve this quadratic equation here. Of course, we can't quite get started yet because my quadratic equation is not in standard form. So the very first thing I'm going to do is rearrange the terms such that it is in standard form. We can do that by adding 5 to both sides to move that negative 5 back over to the left-hand side. That gives us 6x squared minus 4x, negative 47 plus 5, minus 42 is equal to 0. Now I can identify that my a value is 6, my b value is negative 4, and my c value is negative 42. Let's jump into the quadratic formula. We'd say that x equals negative b, the opposite of negative 4, plus or minus the square root of b squared, negative 4 squared. Notice how I'm being careful with my parentheses and my negatives. Minus the product of 4 times a, which is 6, times c, which is negative 42, all over 2 times 6, all divided by 2 times 6, 2a. All right, let's continue. I would say here x equals, the opposite of negative 4 is positive 4 plus or minus the square root of. Negative 4 squared is positive 16 minus this product again. 4 times 6 is 24. 24 times negative 42, that would be great to be able to do in my head. I can't though. 24 times negative 42, we get negative 1008. All right, don't panic. Don't panic. I'm sure it'll work out to a perfect square, right? It must, right? At some point, hopefully. Let's find out. I'd get x equals 4 plus or minus the square root of 16 minus negative 1008 is going to be 16 plus 1008, which is 1024 all over 12. The square root of 1024, please, 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 1024. The square root is, look at that, perfect square. Square root is 32. So I'd be able to say that x is equal to 4 plus or minus 32 all over 12. It's the simple things in life sometimes that make you happy. Getting a perfect square in the quadratic formula, that's one of them. We can now, just like completing the square, split this apart to say, well, x should equal 4 plus 32 all divided by 12, or x could equal 4 minus 32 all divided by 12. Let's see what this comes out to be. 4 plus 32, notice, is 36. And 36 divided by 12 is 3. Over here we get 4 minus 32. That's going to be negative 28 divided by 12. Does not go in evenly, but will give us a nice fraction here. I believe we can reduce both by a factor of 4 to say that x is negative 7 thirds. And those are our two solutions. X is negative 3, and x is negative 7 thirds, or negative 2 and 1/3. All right? Hopefully that made sense. Hopefully you're able to follow all those steps. One thing that I do want to point out about this problem in particular is that if you wanted to, at the very beginning, you could have certainly taken a greatest common factor of 2 in this particular case, making this 3x squared minus 2x minus 21 is equal to 0. And then you could have used the quadratic formula with your smaller numbers. You would have gotten the same answers in the end, but your fractions would have been a little reduced already, like right from the get-go. So regardless, if you take a GCF here or you reduce your fractions in the very end, you're going to end up with the same answer. All right. Hopefully that made sense. So that's nice when the quadratic formula works out to a perfect square and we get nice, pretty solutions like that. Of course, that's not always the case. We can see radicals and i's show up from time to time. So let's take a look at one of the problems where that's the case. Ready? Consider something like this. How about 12x squared plus 5x minus 9 equals negative 10 minus x. Oh boy, look at that. Look at all those terms jumbled around. I'm just going to rewrite my quadratic formula here so you see it, so it doesn't get lost. You might even be singing it to yourself as I'm writing it down. There we go. All right. So before we can even think of using the quadratic formula, we absolutely have to get this in standard form. I have to rearrange my terms and set equal to 0. So I'm going to do exactly that by first adding x to both sides to eliminate this minus x on the right-hand side, and adding 10 to both sides to eliminate that minus 10 from the right-hand side. That gives us 12x squared plus 6x plus 1 is equal to 0. Hopefully we understand how we were able to move those terms around. Now I can identify my values for a, b, and c. I would say here that a is equal to 12, b is equal to 6, and c is equal to 1. I'd use my quadratic formula to say, well, x equals, using my formula, negative b, the opposite of 6, plus or minus the square root of b squared, that's 6 squared, minus the product of 4 times 12 times 1, that's 4ac, all over 2a, that's 2 times 12. Hopefully that's good. Let's see what we get. I get x equals negative 6 plus or minus the square root of 6 squared is 36. Minus this product, 4 times 12 is 48 times 1 is still 48. All over 2 times 12, which is 24. Continuing, I would get x equals negative 6 plus or minus the square root of 36 minus 48. That's the square root of negative 12 over 24. Rats. Well, rats. I have the square root of negative 12. Problem? Well, maybe just for a second, but after that you'd say, oh, wait a minute. I know how to deal with this. The square root of a negative, first of all, has an I that we can pop out, correct? I could say, well, the square root of negative 12 can be simplified to be the square root of negative 1 times the square root of 12. The square root of negative 1 is I. The square root of 12, let's see, the biggest perfect square factor that goes into 12 is 4, because that's going to be 4 times 3. I could say that's the square root of 4 times the square root of 3. The square root of 4 is 2, so I get that the square root of 12 can be represented as 2i times the square root of 3, or 2i rad 3. Hopefully that makes sense as to how we reduce that. Again, as I've mentioned before, this is something that you are expected to know how to do for any one of these problems. So I'm just going to take that 2i rad 3 and replace the square root of negative 12 with it because we determined that's how the square root of negative 12 simplifies. We're left with x equals negative 6 plus or minus 2i rad 3 all over 24. Right? Just taking this 2i times the square root of 3 and inputting it right there. All right. Going forward from here, we see that plus or minus again, so we can split our problem to say, well, x should equal negative 6 plus 2i times the square root of 3 over 24, or x could equal negative 6 minus 2i times the square root of 3 all over 24. In both of these situations, we notice that we can actually reduce these fractions as well. I see this is an even number, this is an even number, and this is an even number. So we can go ahead and reduce that to say, well, x is negative 3 plus 1i times the square root of 3 over 12 here, reducing everything by a factor of 2, just like reducing a fraction. And same exact thing over here. I would say x equals negative 3 minus 1i times the square root of 3 all over 12. And we get our two solutions, one here and one here. All right. Not as pretty and as elegant as the first two solutions, but it is what it is. When you work these out, sometimes you get i's and radicals, and you just have to roll with them. It's no problem. We can do that. I know it doesn't simplify to a concise number, but that is your answer. And notice, this is why something like the quadratic formula is necessary, because a problem with solutions like that, you're not going to get that by factoring. I'll tell you that. And even by completing the square, it would be really, really tricky to work with something like that. The quadratic formula is the way to go. All right. So hopefully it was helpful to see those two examples. Let's take a look now at a word problem. All right. Ready? It's coming your way. Here we go. Ba-ba. So I would definitely recommend copying this down into your notes. I'll try to go slowly and give you some time to do that. You can always feel free to pause the video if you need to as well. This states the formula for projectile motion is given by this. Projectile motion just means an object flying through the air. It's from physics. It's called a projectile. And if a projectile is moving through the air, then it's going to be traveling in an arc, correct? Think about if a projectile goes, if you throw something up and it comes back down, then over time its height goes up and comes back down. It makes that parabolic shape, which is represented by x squared. All right, so not surprisingly, there's a lot of overlap between projectile motion and quadratic formula because they both deal with quadratics. Okay, a lot of physics overlap actually from Algebra 2. So in any case, this says the formula for projectile motion is given by h of t equals negative 16 t squared plus v sub 0 times t plus h sub 0. It then says t is the amount of time an object has traveled, h sub 0 is the initial height, v sub 0 is the initial velocity, and h of t is the height of an object after a given time. All right, it's just explaining what all the variables are. One thing that I want to note to you is this formula is always the same for any projectiles on Earth. The negative 16 comes from the gravitational constant, so I guess if you did it on another planet or some sort of gravity-controlled space, it would be different. But this formula is always the same for any projectile motion problem for our purposes. And it will always be provided to you. You do not need to know this formula. You don't need to memorize it, that is. If you ever need it on any assessment, it will be given to you. All right, just putting you a little peace of mind there. Anyway, this formula is here. Some background information now. We can approach this problem to say, when the New England Patriots score a touchdown at Gillette Stadium, a musket man holds a vintage rifle 6.5 feet in the air and fires a shot with an initial velocity of 125 meters per second. Based on this information, how long would it take the projectile fired from the musket to hit the ground? That's a great question. Notice we have our formula, again, for projectile motion. We have h of t is equal to negative 16 t squared plus the initial velocity times time plus the initial height. It's just a projectile motion formula. Let's fill in what we know. First of all, it says a musket man holds a vintage rifle 6.5 feet in the air. So if you notice, that's the initial height of the projectile. That projectile is held at 6.5 feet. So I'm going to fill that in for h sub 0. It fires a shot with an initial velocity of 125 meters per second. Well, where's my initial velocity? It's right here. I'm going to fill that in with plus 125 times t. And my negative 16t squared stays the same. Lastly, we're looking for h of t. It says, based on the information, how long would it take the projectile fired from the musket to hit the ground? And hitting the ground is a very key word, because think of, if something hits the ground, well, what is its height at that point? If you're measuring the distance it is off the ground and you hit the ground, well, your height at that particular point would be 0, right? So the height when an object hits the ground is 0. In other words, we're trying to look for when this calculation of the object's height will produce the answer of 0, because that would mean that it has hit the ground. All right? Hopefully that setup makes sense, how we're able to plug in our information and set it equal to 0 for hitting the ground. If instead of hitting the ground, if it said how long would it take the projectile to reach a height of 500 feet, well, then we're going to put 500 here, and we'd have to set equal to 0 before using the quadratic formula, right? So whatever the height is that we're aiming for, that's what we put right here. And keeping in mind that hitting the ground refers to a height of 0. Maybe I should write that here for you. This refers to a height equal to 0. All right. So that all being said, now that I have my formula here, we can go ahead and use the quadratic formula. It's a little in reverse order. Usually we see the equation on this side, on the left side, but that's okay. It's still set equal to 0. It's still set in standard form. We can say that this is my A. A is negative 16. B is 125. And C is 6.5. Of course, we have our handy-dandy calculator to help us. Let's get started. We'd say x equals negative b, negative 125, plus or minus the square root of b squared, that's 125 squared, minus the product of 4 times a, which is negative 16, times c, which is 6.5, all over 2a. And again, a is negative 16. Again, slightly scarier numbers than we're used to seeing, or bigger, and we got a decimal in there, but it's just still all the same steps. I would say x equals negative 125 plus or minus the square root of 125 squared. We could turn to the calculator to help us out there. 125 squared is 15,625. 15,625 minus the product of 4 times negative 16 times 6.5. Ready? 4 times negative 16 times 6.5. We get 416, so minus negative 416. All over 2 times negative 16, that's negative 32. Let's keep going. I would say x equals negative 125 plus or minus the square root of, we get 15,625 minus a negative 416, so that's going to be 15,625 plus 416 plus 416. We get 16,041. 16,041 all over negative 32. Hopefully you're still making sense. Again, large numbers, but that's why we have a calculator. Still the same process. The square root of that, hopefully, is a nice perfect square. Rats. Not a perfect square. So what do? Do we try to break down the square root of 16,041 to try to find the biggest perfect square? Well, I mean, I guess you could try, but good news for us is that with word problems, with applications, we are permitted to round to the nearest, let's say, thousandth, the nearest 3 decimal places. The reason why we round in word problems is because in applications, we're going to be looking for those approximated answers. That's just how we communicate with each other, right? I wouldn't say, oh, it takes something 2 radical 3 seconds, we would approximate what that value actually is, right? Let's, for the purposes of our class, round to 3 decimal places. So I could say that my square root of 16,041 is 126.653. All right? So let's say that we can say x equals negative 125 plus or minus, what was it again? I have to remind myself, 126.653 all over negative 32, approximating to the nearest thousandth. All right? Now we can split into our 2 parts. I'm going to do it this way just to give myself a little bit more room. We can say x equals negative 125 plus 126.653 all over negative 32, or x equals negative 125 minus 126.653 all over negative 32. This first calculation will give us, let's see, negative 125 plus 126.653. We get 1.63653 all over negative 32. Gives us an answer of, looks like 0.0517 if I round to 3 decimal places, negative 0.0517 for that one, right? And over here, if I approximate to 3 decimal places, let's see what we get. Negative 125 minus 126.653. We get negative 251.653. And we're going to divide that by negative 32. And I would get an answer of 7.864. Hopefully everybody sees how we got that. Now, the question I have for you is, which of these makes sense as a solution? Do they both make sense? Does one make sense and the other not make sense? Or do neither of them make sense? Hopefully realizing that this represents the amount of time that it would take to hit the ground. And really, these should be t's, not x's. T equals, right? Because we're variables t. But regardless, if this is the amount of time it takes for the object to hit the ground, we would say, well, is it going to hit the ground after negative 0.0517 seconds? That doesn't make any sense, right? Do you see how this wouldn't really make any sense at all? Actually, I guess this should be 0.052, right, if we're going to round. But regardless, this doesn't make any sense in the context of my problem. We can't have something take a negative amount of time. So using a little logical thinking, I would say it doesn't make sense to have a negative amount of time. I'm going to eliminate that answer and say that it has to be the 7.864 seconds. All right. Hopefully that made sense as to how that was done. Again, bigger numbers than we may be used to seeing. We even saw some decimals pop up, but it's just a matter of plugging into the quadratic formula, figuring out what your answers are. With applications, and only with applications, we can approximate to the nearest 3 decimal places. With regular quadratic formula problems, we are keeping things in exact radical form. But for our purposes here, since again it's an application, we approximate. We determine also that one of those solutions doesn't make sense in the context of the problem. So we would say that it takes approximately 7.864 seconds to hit the ground. Wrap it up in a nice little sentence there. All right? Awesome. Hopefully that made sense. Please feel free to go back and review it if you need to. Also, please try the practice problems on Google Classroom. Again, just as a little recap, we did a quadratic formula example here, which was great. We did another one here that worked out to be radicals. And then we took a look at a nice in-depth look at a projectile motion word problem. All right. Thank you so much for your attention and focus today. Again, try those practice problems if you can. We'll practice for the rest of the week, and I hope you enjoy the rest of your day. See you later. And remember to sing that quadratic formula song. Take care.